Okay, very good morning, student. Today we can continue our topic of physics, that is the gravitation. Okay, yesterday we have learned the Newton's law of gravitation, and when we are learning the Newton's law of gravitation, then at that time I have already explained to you every body in the universe attracts to every other body with the force which is directly proportional to the product of their masses and inversely proportional to square of the distance between them. Okay. Now that we have calculated f is directly proportional to m1, m2 and f is inversely proportional to r square. So therefore f is directly proportional to m1, m2 upon r square. And if you are removing the proportionality sign, then we are just adding here constants of proportionality, that is f is equal to minus or g m1 m2 upon r square, where g is the gravitational constant. Okay. Today we want to learn the Newton's law in terms of gravitation in a vector form. Okay. So in a vector form means with the direction, means when the two particles or two objects, okay, we can consider the point mass which we have considered, which are separated by some distance, is supposed to be r. Okay. And now these two are the point masses, means distance between the two particles is very large as compared to the radii. Okay. Now in vector form, while you are showing that Newton's law of gravitation, then at that time you see here, so as that m1 is exerting force on m2, the same meanwhile m2 is also exerts force on m1. So there is a force of attraction between that is the two masses, and so that force of attraction in a vector form we can write down. So here that is the F1 2 force exerted on one particle, first particle, by the second particle will be in this direction. Means this particle is pulling to the first particle F1 2, and which is given by minus G m1 m2 upon r square, and into this unit vector which we can give here, that is the r21. Okay, so that will be the your unit vector. So now that vector will give you the direction, actually in which direction that force is exerted. Force exerted on one particle by the second particle means towards 2 to 1, and so therefore this particle or this object is going to get pulled by the second object. Now if I want to calculate F21, force exerted on the second particle by the first particle, means now what happens, this particle is exerting a force on second particle. So therefore naturally second particle is going to pull towards the first particle. So therefore this will be the F21. And when you are talking about F21, force exerted on the second particle by the first particle, so then now you see here that equation will becomes minus G m1 m2 upon r square into r12. Okay, so that will be the your unit vector, means, and the direction of unit vector r12 is towards this direction, with this force exerting force on the second particle. Is it right? So now here in that case we can say, sir, what is F12? So that will be the force on first particle by second particle. Second mass, force on first particle or first mass by the second particle's mass. F21 is equal to force on second particle or second mass by the first particle's mass. Okay. Now R12, R12, this is the your direction of unit vector. Okay, in which direction actually this vector is exerting. Okay, so here if you want to say R12, this is the unit vector from first particle to second particle. Unit vector from first particle to second particle. Okay, so that will be the your R12. Then now if you are talking about R21, R21 is the unit vector from second particle to first particle. Okay, but if you observe R21 and R12, okay, so they are equal in magnitude but opposite in direction. So therefore R12 is equal to minus R21. R21. Okay. R12 is equal to minus R21. And if I will say R12 is equal to minus R121, then now these equations will become, so F12, I will write down here, F12 is equal to minus Gm1 M2 upon R square into R21. Okay. And F21 is equal to minus Gm1 M2 upon R square into R12, means here this will be the negative R12, or here R12 can be written as minus R21. So minus minus it will become plus. Okay. And so therefore F12 becomes minus F21. Okay, means these two forces are equal in magnitude but opposite in direction. And what is negative sign showing? Negative sign is due to force of attraction. Force of attraction. One mass is always attracted towards the another mass due to your gravitational force. Okay. So that will be the your Newton's law of gravitation. Once you got that F12 is equal to minus F21, then now some question arises, sir, this is the Newton's law of gravitation in a vector form. Okay. Now question arises, sir, if suppose you are throwing any apple or any body, that means above the surface of earth, then why this body falls towards the ground only? So actually here there are the two bodies are there. Yeah, one is the earth and second is that body. Okay. Now if you can take only example of apple, why the apple falls on the surface of earth? Actually force exerted by the earth on the apple will be the same as force exerted by the apple on the earth. Then question arises, why only apple falls, why the earth is not pulled by the apple towards it? So the answer is very simple. Though these two forces are same, but the apple falls only due to the acceleration produces here like this. What is that acceleration? A is equal to force, because force is equal to m into A. A is equal to F by m. Now you see here, bachalo. So as the mass of the earth is very large, mass of the earth is very large. So therefore acceleration produces on the earth will be very small. Okay. So as compared to apple. And so therefore mass of the apple is very small. So therefore acceleration produces is very large. Okay. So therefore as mass of apple is very small as compared to mass of earth. So therefore we can say that the acceleration produces on apple very large as compared to acceleration produces on the earth. Okay, so therefore apple only attracts towards the earth and earth is not attracted towards the apple. Okay, you just remember that things, why these things happens. Okay, now you have learned about the gravitational constant also, G, what are the units, dimensions, all these things yesterday I have already explained to you. Now we want to learn some characteristics of the gravitational force. Okay, so yesterday only we have learned what is the gravitational force and what are the characteristics of gravitational force. Can I rub this now? Okay, if you have finished, then now we can proceed for the next points. What are the characteristics of gravitational force? What is the principle of superposition and how the gravitational force is? That means we can calculate in case of the different masses. Okay, assuming that you have learned everything, you understood that things, then we can come to the point again. So what is exactly that gravitational force and the properties or characteristics of that your gravitational force? Okay, gravitational force or properties or characteristics, okay, of gravitational force. Okay, bachalo. Now you have learned what is a gravitational force. The gravitational force which has been given by the Newton in his formula. So the force which exists between the 2 point masses, and F is directly proportional to m1 m2 upon r square. So therefore, if you are removing the proportionality sign, then F is equal to G m1 m2 upon r square. So here in that case, this force is called as the gravitational force. Okay, that is called as gravitational force. Now sir, what are the characteristics of this force then? First characteristics, yesterday also I have explained to you. Some few important characteristics. This is always attractive force. Which is that force? Attractive force means one mass is always attracted towards the another mass. Okay. Second, this is the central force. Okay, this is the central force. Okay, it is always attracted towards the center. Means, for example, if I will take that means these two bodies, and this is the separation of the distance m1, m2, then they will always, that means trying to pull another body towards its center. Okay, so therefore it is always lying in the same straight line and attracted towards towards its center. So therefore it is called as the central force. This is the weakest force in the universe. Okay, weakest force in the universe. Okay. Now this force is the long range force. Long range force. Okay, long range means up to sir what? So near up to the infinity, that force can be exist. Okay, up to infinity it can be exist, but if you put the infinity, the force will become 0, because anything upon infinity will be 0. Means now you have to consider your infinity up to 100 meter, 200 meter, 300 meter. So up to one body will be attracted towards the another body. That is the long range force. Okay, it is the conservative force. It is the conservative force. Sir, conservative force means what, sir? This force does not depends upon. Okay, so this force does not depend, or work done by this force does not depends upon the path followed by the particles. Means you can calculate this gravitational force any way you can go. Gravitational force will be remains same. That work done does not depends upon the, that is path followed. So that is called as the conservative force. Okay. This force is considered to be a negative, always attractive. So therefore it can be considered as a negative force. Okay, always attractive force. So therefore it is also called as negative force. Okay. So now if that means here this is always comes in action reaction force, mutual force which comes in action reaction, means F12 is equal to minus F21. Okay, means according to Newton's third law of motion, F12 is equal to minus F21. Means these two forces are equal in magnitude, opposite in direction. Okay, so these are the different characteristics of that your force. Now once you got that gravitational force, then we are coming to the point, sir, what is exactly principle of superposition for gravitational force? Okay, so now we can proceed for that. What is the principle of superposition? Okay, yes. So principle of superposition, if I want to explain to you, you have learned that principle of superposition in case of, that is in electrostatics also, or in waves oscillations. So that point also you have learned that is your principle of superposition. Okay, principle of superposition, principle of superposition. Okay, so what this principle is telling. So now for example, so that this example we can say like this, principle of superposition. In case of the waves you have learned, when two or more than two waves traveling through the medium arrive at a point simultaneously, each wave produces its own displacement independent of the other, but the resultant displacement at that particular point is the vector summation due to all the waves. So that is what you have learned for your principle of superposition in case of the waves. Same principle can be used for the charges also, same principle used for the masses also. So what in that means gravitation, what is the principle of superposition? So it states that the resultant gravitational force acting on a particle due to a number of other particles is equal to, means suppose there is one particle and on that particle, suppose there are the different particles m1, m2, m3. So they are exerting a force on that particle, okay, m3, m4. So then now, so that when acting on the particle due to the number of other particle is equal to the vector sum of gravitational forces exerted by the individual particle of the given particle. Means what happens, if suppose in the medium there is a one mass and on that mass, so there is another, first mass is also exerting force, second mass is also exerting force, third mass is also exerting force, fourth mass is also exerting force. So what will be the resultant force? So that will be Fr. And so if you want to find out Fr, so that can be written as F1 plus F2 plus F3, F1, F2, F3 plus F4. And if there are the n number of forces are there, then that resultant force can also be written as F1 plus F2 plus dash 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 Fn. Okay, so these are the n number of forces which are acting on the particle. So therefore, I can say summation of Fi, okay, summation of Fi where I varies from 1 to n. So that is called as principle of superposition. Okay, resultant force. If you want to calculate on that, then you can calculate the force exerted by the first particle on that mass m, and as if another masses are not there, okay, then you can go for the second particle, then go for third, go for fourth, and calculate all the force exerted, summation of all these forces. So that is called as the principle of superposition. So then when we are using that principle, suppose now for example, and that means according to above principle, for equilateral triangle I want to use this principle, okay. So for equilateral triangle, I want to use that principle. So now here in that case, in equilateral triangle, bachalo, if suppose there are the three masses which are kept at the three vertices of that triangle, okay, m, and all the three sides are supposed to be equal. Then now if suppose there is a one point which has been kept on the centroid, okay, of that your mass m. So then what will be the resultant force acting on that mass? Okay, if that triangle, all the sides are the same, L, 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 L. So therefore, resultant force acting on that particle will be 0. Okay, because, so here resultant force, Fr will be 0. Because this force is attracted by equally to this force is attracted with this force is attracted with this, means that the summation of all these forces if I will do, so that resultant force acting on the net gravitational force acting on that body will be always 0 if this is the equilateral triangle. If I will consider for a square, okay, for suppose for example if I will take a square, okay, if square have, that is all the four sides are the same, suppose this is the square, and now that means side of the square is L. Side of the square is L, 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 L. And the four equal masses at the kept at the four corners of that square. And if I will take, that means there is a one particle which is kept at the exactly the interpoint of intersection of that diagonals. Then what will happen, again the resultant force, means force exerted by this particle on this particle will be the same as this on this, will be the same as this on this. And so therefore the summation of all the forces, means here again Fr resultant will be 0. Okay, that all the forces, means whatever may be the force exerted by this m on this m on this m on this m, they are equal in magnitude, opposite in direction. Okay. Now if suppose I will take again the squares, but the masses are not the same. Third condition, if I will say, if sir, this is the square, But in that square, there is another mass which have been kept at the point of intersection of the diagonals. Okay, but these masses are like this: m1, m2, m3, m4. Okay. So now if here again m1 is equal to m4, ये और ये same है, और m2 is equal to m3. So what will happen, you know? m1 एंड m2 सेम है तो फिर रिजल्टेंट जीरो हो जाएगा, ये अगर सेम है तो रिजल्टेंट जीरो हो गया, तो फिर समेशन ऑफ रिजल्टेंट फोर्स एक्टिंग ऑन द बॉडी विल बी अगेन जीरो ऑन दैट बॉडी, दैट मींस व्हिच हैज बीन केप्ट नियर द पॉइंट ऑफ इंटरसेक्शन ऑफ दैट योर diagonals. Okay, but now sir, suppose this all the masses on the diagonal, each diagonals are not the same. Suppose for example, if I'll take this is the square L, 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 and these masses m1, m2, m3 and m4, if I will say like this, m1, m2, here m3, m4 I have done, but here suppose I am taking the different masses. Now suppose for example here m1 is equal to m3, but m2 is not equal to m4. Here अगर यहाँ पे तो ये दोनों सेम है तो फिर they will cancel the effect of each other on this mass which is kept at the point of intersection of O. But as m2 and m4 are the different, then which mass is more? According to that there will be a subtraction of these two forces. So suppose m4 is greater than m2, then m4 minus m2, force exerted by this minus force exerted by your m2. So that we have to calculate. Okay, so that means you have to always subtract smaller force from the larger force. Okay, so this is the all about the principle of superposition. Okay, now we can proceed for the gravity. Okay, so now okay, so now we can say, sir, what is exactly gravity and what is acceleration due to gravity and what is acceleration due to gravity at the different points. So that points we want to learn now. Okay, so now once you got that that means gravitational force and the principle of superposition in case of the gravitational force, then now we are coming to the point, sir, what is exactly gravity or acceleration due to gravity? Acceleration due to gravity. Now its name itself indicates, okay, that means acceleration produces by any freely falling body due to gravity, that is called as acceleration due to gravity. Suppose this is the body having the mass m, and if this body has been falls, that means from the height h, okay, so on the ground, so then here and that time force exerted by the gravitational force on the body, and so therefore acceleration produces into that body, and this acceleration due to gravity. Gravity, this word always use when you are using, that means your earth is attracting to this body towards the itself, so therefore acceleration due to gravity. Okay, this is denoted by g, that is the g, and here this is the acceleration due to gravity. You know what is the value of acceleration due to gravity? G is equal to 9.8 meter per second square, means SI unit of acceleration due to gravity is meter per second square, and CGS unit of this acceleration due to gravity is centimeter per second square. Okay, you remember that things. What is that? SI unit and CGS unit. So what are the dimensions of acceleration due to gravity? As this is the acceleration only, so therefore dimensions will be m0, L1, t raised to minus 2. So these are the dimensions of acceleration due to gravity. Once you got the idea about, sir, what is that acceleration due to gravity, then now, sir, how we can calculate that acceleration due to gravity. Now you can consider, suppose this is the earth, and on the earth surface this is the mass which is lies on the surface of earth, and if this is the O, center of earth, and R is the radius, if m is the mass of the earth, then now here in that case I will say, sir, how much force is exerted by the earth on that body. So here in that case force exerted will be Gmm by r square, where r is the radius and capital M is the mass and small m is the mass of the body. Okay, Gmm upon r square, if this is the first equation. But now if I'll say capital F force is equal to m into g, capital F is equal to m into g. And if I will substitute this value, because force is equal to mass into acceleration due to gravity. So if I will substitute this value in equation 1, so therefore m into g is equal to gmm upon r square. So small m get cancelled. So therefore acceleration due to gravity g is equal to gm by r square. Okay, what is the acceleration due to gravity? So that is equal to gm by r square. So acceleration due to gravity does not depends upon the mass of the body, whether it is a smaller mass or bigger mass. The acceleration produced by the earth on that body will be remains same. So that is the gm by r square, does not depend. But here we can definitely say G is inversely proportional to r square. Okay, square of the distance between the two particles, separation of the two particles. Okay, so that if this distance is r is the radius of the earth. So G is inversely proportional to r square, means as the r is more, G will be less. Okay, or r will be less, G will be more, inverse variation. So now from that we can also say that G1 by G2 is equal to R2 upon R1 square. Okay, G1 by G2 is equal to R1 by R2 square. Okay, so that will be the your acceleration due to gravity. Okay, so now we can say here in that case, suppose G1 and G2 is directly proportional. G1 G2 is equal to R2 upon R1 square. So now here question arises, if sir G on what factor G will depend. So G will also directly proportional to mass of the earth, radius तो h, mass पे भी वो depends करता है. Okay, if suppose बच्चे लोग m is decreases by x%, तो G will also decrease by x%. Okay, you remember. Okay, so now if suppose I want to write down in terms of, that is your density. So this equation can also be written in terms of the density. So in terms of density, how we can write down that equation? As G is equal to Gm by R square. But density is equal to mass upon volume. So therefore mass is equal to density into volume. Okay. So as the density into volume, so therefore I put here this value, G is equal to G density into volume by R square, or G is equal to G into rho into 4 by 3 pi r cube upon r square. R square will get cancelled. So G is equal to 4 by 3 rho G pi into r. So therefore from this equation we can also say like this, student, if rho is remains constant, if the density of the body will remains constant, then G is directly proportional to R. G is directly proportional to R. You see here, G is inversely proportional to R square. When the mass of the earth will be remains constant, G will be remains constant. But if here density will remains constant, then G is directly proportional to R. Or we can also say that G1 by G2 is equal to R2 by R1. Okay, so you just remember, so how that G will be related with the, that means your radius. Okay, so here if suppose we can say that sir R is increased by 1%, so G will also increase by 1%. Here if R is increased by 2%, okay, so then so that will be 2 into R by R. G will be, here if this is increases, G will be decreases. So that was the relation, or that is the relation between acceleration due to gravity. Now we want to calculate variation of G above the surface of earth. Okay, but that we can see in the next period. Okay.